Sample problem number 2. If the T-beam shown is uncracked, calculate the stress in the concrete at the top and bottom extreme fibers under a positive bending moment of 80 foot kip. B. If the strength of concrete, or FC prime, is equal to 3,500 psi and normal weight concrete is used, what is the maximum uniformly distributed load that the beam can carry if it is used as a simple beam with 25 foot span without exceeding the modulus of rupture of the concrete? And C. Repeat B if the section is inverted. So first, we have to account for the given data. So if we look at the drawing, we are given the width of the flange. We call this one BF. The width of the flange is 60 inches. Then we are given the width of the web, which is 12 inches. Next, we are given the height of the flange. This one is 5 inches. And we are also given the height of the web. This is the web. And this is 27 inches. So the total height now of the entire beam will be 5 plus 27. And that is equal to 32 inches. Right here. Then FC prime, of course, is given in letter B. That is 3,500 psi. Moment is also given in question A. That is 80 foot kip or kip foot. And since this is a normal weight concrete, the value of the lambda is 1. And we are also given the length of the beam. No, actually this is a simple beam with a length of 25 feet. Alright, so we now answer or solve the problem. Question A is we are to find the stresses in the concrete at the top and bottom. So stress in the concrete at the top and bottom. So if you think of stress, always recall the formula MC over I. Now FB is equal to MC over I. This is coming from the strength of materials formula, basic formula for bending stress. Now, since we are in concrete design, this FB will now be simply F, whether top or bottom. Then M is the bending moment. The C is your distance from the neutral axis to the outermost tension or compression fiber, and I will be your IG. Okay? IG. And this one will be your Y. Alright? So, how do we solve IG first? Because moment is already given in the problem. Here we have 80 foot kip. And C, we can solve C if we know the neutral axis. Alright, we can solve C if we know the neutral axis. Where is it located? And we can determine the neutral axis by using this formula. Okay, this formula. Area total is, or area total times barred Y, or the centroid, the location of the centroid or the neutral axis, that is equal to the summation of area 1 times Y1 plus area 2 times Y2, so on and so forth. Now, if I'm going to write it for a better understanding of the formula, so area total times barred Y, that will be equal to the summation of area 1 Y1 plus area 2 Y2 then so on and so forth. Alright? So, we are going to divide the beam into two areas. Alright? This will be my area 1. I will consider this one as my area 1. So, I'll call this area 1. And this will be my area 2. Area 2. Okay? So, area 1, if this is, by the way, 60, and then this is 12, so that will be 48. And then 48 divided by 2, that will be 24 inches here. 24, 24, and then we have 5, and then 5. Okay? So we have, sorry, this is still area 1. This is part of area 1. Let me shade it for a better illustration. Area 1 is shaded and area 2 is not shaded. Alright, so area 1 is 24 times 5 times 2. Okay, so that will be 240 square inches. Okay, and area 2 is simply 12 times the total height, which is 32. And 12 times 32 is equal to 384. Okay? Now, let us measure the centroid of each individual area, the distance from the centroid of that area towards the top of the beam. Okay, the centroid of this area is somewhere here, and the centroid of area 2 is somewhere here. So, measuring the centroid, that will be 2.5. And here, this will be half of 32 because the entire height is 32. So, that will be 16. So, 2.5 and 16. So, 2.5 and 16. Now, let us multiply the area times the y. So, 240 times 2.5. That will be 600. Next, 384 times 16. That will be 6,144. Okay? Now remember, in the formula, you are going to sum. You are going to sum all of the areas times the y. So to sum the two, you add the two, you will generate an answer of 6,744. Okay? And to get the barred y, you have to cross multiply or divide both by area total. So therefore, transfer it here. That will be your area total as the denominator. Okay? So, the area total now is 624. So, therefore, 6,744, which is this one, divided by the total area, which is 624, you will generate an answer of 10.81 inches. Kindly calculate, pause this video and calculate so that you'll be able to verify the answer. Next, we are now going to compute for the IG. Okay? And the IG has this formula. IG is equal to the summation of IO plus A times Y squared. Okay, what are these values? Let's find out later. Let me just write this down for a better understanding of the formula, IG equals the summation of IO plus A times Y squared. Okay? So, let us now solve the problem or the IG. What is IO? IO is simply BH cubed over 12. Now, IO is BH cubed over 12. So, for the first area, B, what is our B? B is 24 times 2, no? So here we have, let me just put an arrow in it so you can clearly see. So that will be, our B here is 24 times 2 or 48. And our H here will be 5 inches. So BH cubed over 12. So that will be 48 cube. No, sorry. 48 times. Okay, a little mixed up. So 48 times 5 cube over 12. So you will generate this answer. Okay, 500. Okay? And similar to area 2, your B now will be 12 inches and your H will be 32. So 12 times 32 cube over 12. And you will generate this answer. Alright? So, next is to account for the Y. To solve for the Y is the distance from the neutral axis to the centroid of that individual area. Okay? The distance from the neutral axis to the centroid of that certain area. So, what is our centroid now? The centroid is 10.81. So, it is located somewhere here. It is located somewhere here. So, let's say this is your barred Y and it has a value of 10.81 inches. Okay? So, the centroid of this individual area is located 2.5. 2.5 from the top. Here, this is the centroid. So, the distance now from this centroid to the centroid or the neutral axis of the entire section is this. And that is simply 10.81 minus 2.5. And it will generate an answer of 8.31. And for the second area, we know that the centroid of this area is 16. So 16 minus 10.81. So 16 minus 10.81. And that will be 5.19. Now, this one has a parenthesis because it generated a negative answer in my formula. But that's okay because we are going to square the area anyway, or square the value. Okay? So, for area times y squared. So, this area here, 240 times y squared. So, 240 times 8.31 squared. That is the answer. Next is 384 times y squared, 5.19 squared. So 10,352.66. And now, for the IO plus a y squared, simply add the 500 to this and you will have this answer, as well as the other area. And then the IG, as I said earlier, is the summation of IO plus AY squared. So sum 17 plus 43,000, you will generate this value. That is in terms of inches to the fourth. So 60,184.92 inches to the fourth. And that is your IG. Okay? That is the most difficult part. Now, we come now to the easy part, which is just a manipulation of the basic formula, which is MC over I, to get your FB. So, hence, we get FB is M times C over IG. Now, why is there a bottom and the top? Now, bottom, from the neutral axis, this is the stress at the bottom, no? Because the bottom part will be stressed, no? In this manner, the stress will be in this manner. The bottom will have a bigger stress. If this is the graph, it will be reduced until it will become 0 at the neutral axis, and the stress will also increase proportionally at the top until it maximizes at the top part. This one is your neutral axis. So here, to get the stress at the bottom, then we use C at the bottom. And what is our C at the bottom? The C at the bottom is 21.19 inches. Recall that this is the location of our, let me extend this drawing, the location of our neutral axis. So therefore, what is this value? That is equal to 32 minus 10.81. That will be 21.19. So hence we have this 21.19, and plug in the 21.19 to this formula here, you will generate this answer. Of course, the moment shall be multiplied by 12,000 because the value of the moment is 80 foot kip, and you have to multiply it to 12,000 to convert it into pound inch. So your answer will be in PSI. In the same manner, for the bottom part, the C at the top is 10.81 inches here. So for the F at the top is MC over IG. The C will be, the C to be used is the C from the neutral axis to the top fiber. So using the same formula, you can generate this answer. Alright, so let's go to problem number 2. Cracking moment. So let's solve first the rupture stress, which is 7.5 times lambda times square root of FC prime. Now this again is a normal weight concrete. So if this is a normal weight concrete, it means to say that the lambda is equivalent to 1 here. So plug in the values and then you'll be able to get this answer, 443.71 psi. And for the cracking moment, what we are going to use is the C tension. Why? Because the load is at the top. If we look at the side view or the profile view of the beam, the load will be at the top. This, by the way, will be our support, and then this will be our load, uniformly distributed load at the top. And as you can see there, the bending will cause the bottom part to be in tension and the top part to be in compression. Okay? So since we are reckoning from the tension part, so we use the C tension. So that will be 21.19. Alright? So, again, just to clarify, the beam will crack at this portion, at the tension side. Okay? So, since the beam will crack at the tension side, so we are going to use C tension. So, to get the moment, we use again this formula, manipulate this formula, and then we generate this answer. The answer normally will be in pounds foot, but you have to divide it by 12,000 to get foot keep. Now, why do we want foot keep? Because the problem says that we are going to determine the uniformly distributed load. Uniformly distributed load. Alright? So, for the uniformly distributed load, since this is a simple span, so the formula for moment maximum is WL squared over 8. And then we are given the moment, which is the cracking moment, and we are given the length, which is 25 meters here. And we are going to solve for the W. Okay? So the formula now for W is 8m, because we cross multiply 8 here, over L squared. Now, remember the units. Moment is in kip foot. L should be in feet, so that we can generate this answer here. 1.34 kip foot. Next, if the beam is inverted. What if the beam is inverted? Such that the lower portion will absorb the tension stresses. Okay? This will be now the neutral axis, and the lower part will absorb the tension stresses. So, just the same, use the C tension. And what will now be the C tension? This value here, which is 10.81. So, the C tension will be 10.81. And just the same, to get the cracking moment, we use the formula here, but instead use the FR. So that will be 205.91 foot kip. Now don't forget to divide it by 12,000 to generate the foot kip answer. And then, to solve for W, again, we use this formula. So the answer will be 2.64 kip per foot. Okay? So as you can see, if we invert the beam, it will have more capacity to carry load before it will crack. Unlike this one only has 1.34 kip and then it will crack. But here, since there is more area below, then it can support more load. Alright, thank you very much.